I need to talk about something very important about partial measurement. We already learned the measurement, we learned the projection operator, which is fine. But now I have a lot, 2 qubit, right? Let's just review, right? For a single qubit, right? Maybe I have psi equal to alpha 0 plus beta 1. And then I measure, what will I get if I do a measurement on this in the basis 1 or 0? Yes, it will collapse, right? Remember, it will collapse to 0 or 1. With what probability? You already done the assignment, alpha square or beta square, right? With probability, alpha square, beta square. That's okay, good. Now you have a 2 qubit system. Then, of course, it can be a linear combination of 4 states, right? This A10 and then A11, right? If I do a measurement, what happens? If I measure, okay, both qubits, right? I'm measuring both of the qubits. What are the possibilities? What will I get? Very good. 0, 0, 0, 1, 1, 0, 1, 1. You only have these 4 possible outcomes, right? Collapse. It collapses to the basis state. It's very wrong. This is not difficult. For example, this corresponds to A00 square. This one you have a chance of A10 square, right? Now, what if I don't measure both of them? I just I say that wrong. Okay, 1, 1, thank you. I only measure, let's say, the first qubit. I have the liberty to do that. I have 2 electrons, right? Instead of measure, I just measure on that. What are the possibilities? Okay. Well, the first qubit can collapse to either 0 or 1, right? Because I only measure one of them. Almost like it's not a good joke, but let's say I like 2 girls, right? Both of them, I don't know if they like me or not, right? They are linear combination. I only ask one girl, then only the state of that girl will collapse to either 0 or 1, right? Not both of them. Correct? Okay. Now, what is the for example, what is the probability of getting 0? I'm measuring the first one. What's the probability? No. I have this equation. It says A00 square plus A01 square. Do you agree? Can you explain why? Right, very good. Or I try not to say the whole system collapsed because the second system has not collapsed yet. But you are right. I would say the first qubit collapsed to 0. There are 2 ways it can collapse. One is the system collapse to 0, 0. Another is the system collapse to 0, 1. Both of them will give me the measurement of 0. And this is the so-called partial measurement, which is very important. Yeah? Now, what the wave function will be after this measurement? What will it be? It will become A0000 plus A0101. Okay, after it collapses. Because it doesn't have the one component anymore for the first qubit. So when you have a partial measurement, then you have the basis that with the basis that corresponding to the collapse of the first qubit still remain. Others will be gone. Is this correct? Why? Very good. He said that the probability does not sum up to 1 now. Because originally, this is normalized. Originally, A00 squared plus A01 squared plus A10 squared, maybe I should even write here, right? We have, for this case, we have alpha squared plus beta squared equal to 1. We normalize all vector in quantum computing. Here we have A00 squared plus A01 squared plus A10 squared plus A11 squared, sum to 1. So now, if you write in this, it's no longer e to the 1. So what do we need to do? We need to renormalize. Very good. How do you renormalize? Can you guess? Well, silly. Very good. Divided by the length, right? What is the length? A00 squared plus A01 squared. Yeah. Very good. You guys know a lot. So we will stop here. The progress is okay today. Okay.